Here we go, video 6.4% composition. Let's get started. Alright, what is percent composition? Well, percent composition is pretty much very similar to percentages you found before. For instance, let's say we were in a classroom that had 22 people in it. And let's say 10 were men and 12 were women. And I said, okay, what is the percent composition of the women in the classroom? What's the percentage of the women in there? Well, there are 12 women, and we divide it by 22, which is the total number of people. Alright? And we get an answer of 0.54. Alright? And then if we took that, and with percentages, we like to multiply by 100%. Alright, I don't need a calculator for that. You get 54%. So 54% of the people are women, which would leave, and it's kind of, when you can do this, if you did it for men, you would figure out it was 46%. And then when you add those up, it should equal 100. Okay? It's going to be the same thing, except we're going to look at the percent composition, or the percent mass, of elements inside of compounds. Alright? The easiest way to understand this is just do some problems. Alright, we will need this periodic table, so I'll be flipping back and forth to look at this periodic table. Or we might need the periodic table. We'll see. Alright, what is percent composition of NaCl? Okay, so this is just a problem. This is what's percent composition of NaCl. Look here, they didn't give us any numbers. So what are you supposed to do here? Here's where you start. First thing you do is find sodium on your periodic table. So we'll go back. And there's sodium. Sodium is right here, and it's 23.0 in terms of its mass. So 23.0 grams. Alright, you can put grams per mole. That's the molar mass of sodium. Okay? Chlorine. Let's find it. Chlorine is right here. Its molar mass is 35.5 grams per mole is its molar mass. Okay? So when you're doing percent composition of a compound, alright, what you do is just pretend that you take your molar masses and just make sure they're in grams. So we have 23.0 grams of sodium, and we have 35.5 grams of chlorine. What's the next thing you do? Add these up to get the total. So add these up, I get an 8, and then I get 58. So I get 58.5. Basically, this is the molar mass of this compound. Alright, when doing percent composition of an element, or sorry, of a compound, what you do is you look at each of the individual elements. Okay? So we go back in the problem, we look at 23 grams of this total came from sodium. So for this sodium, you take 23.0 grams, and we're going to divide it by the total, which was 58.5. So 23.0 divided by 58.5, and my number comes out to be 0.393. Okay? And then I'm going to multiply this by 100% to get it in percent form. So when I do that, you get 39.3%. So this is the percent composition of sodium and sodium chloride. You also, unless it specifies, you'll do both. So let's do chlorine now. 35.5 grams, alright, of this came from chlorine. We're going to divide by the total again. So the total mass of sodium chloride puts us in our calculator, so 35.5 divided by 58.5. And in my calculator it tells me 0.607. I'm going to multiply that by 100%, and I get 60.7%. Alright, this is percent by mass of chlorine. Okay, so your percent composition of chlorine or percent by mass is 60.7. If you wanted to check yourself on these once you do this, just add them up and they should be equal to 100. If I was to add this, it would equal 100. Let's go to another problem. All right, what's percent composition here? Once again, I need to look at all the elements. So, first thing we're going to do is find calcium. All right, calcium is 40.1 on the periodic table. I'm just going to go ahead and put that in grams, 40.1 grams. All right, next, nitrogen. We find nitrogen, it is 14.0. So we get 14.0 grams. And then lastly, oxygen. If you flip back here, oxygen is 16.0 grams. So here we go. Oxygen is equal to 16.0 grams. Now, in this compound here, calcium, there's one of them, so it stays. When we look back at our last problem, we had one of each, so we didn't really need to do anything with this. But if you look in our formula here, we have one calcium, but we have inside the parentheses, this subscript is 1 for nitrogen, but outside the parentheses there's a 2, and if you remember, you need to multiply these. So we have 2 nitrogens that make up calcium nitrate, so this needs to be multiplied by 2 to get us 28.0 grams. Same thing for the oxygen here. I got 3 inside the parentheses, 2 out. These need to multiply. This gives us a total of 6, and 16 times 6 is going to give us 96.0 grams from oxygen. We're going to add these up to get the total value. So 40.1 plus 28 plus 96. So I'm going to do that in my calculator real quick. Makes it simple so I don't make a mistake. And we have 164.1 grams. So this is the total mass of calcium nitrate. So when you do percent composition, I'm going to take my 40.1 grams from calcium divided by my 164 point, oops, my point's in the wrong place, 0.1 grams, that's 164.1. So I get 40.1 divided by 164.1. Okay, I get 0.244, and then I'm going to multiply this by 100%, which is going to equal 24.4%. So for the calcium, it's 24.4%. Nitrogen, I'm going to take this number here, 28.0 grams. So it's the number after you figured out how many nitrogens are in there and multiplied, okay? So make sure you're careful on that. So 28.0 grams divided by 164.1 grams. 28 divided by 164.1. And I get 0.171. I'm now going to multiply by 100%. And now I get 17.1%. So, I'll circle these. This is for nitrogen. So this is your nitrogen. This is your calcium. One last one. We got the oxygen. So 96.0 grams divided by 164.1 grams. 96 divided by 164.1. I'm going to make my decimal place a little better there so you can see it. Alright, and I've got 0.585 multiplied by 100%, and this equals 58.5%. And there's your percentage for oxygen. Alright, and if you wanted to check yourself, add these up, and it should equal 100%. Alright, let's look at another problem. What is the percent composition of a compound made of 56 grams of nitrogen and 64 grams of oxygen? Now, I really like these because this is actually even more straightforward and simple. You don't need to go to the periodic table on this one if they give you the grams. If they go ahead and give you the grams, you don't need to go to the periodic table. All you need to do is take your grams and add them up. Okay? So I'm going to add these up. I got 110 grams. Alright? And then do your percentages. So 56 grams came from the nitrogen, so this is the nitrogen here, divided by 110 grams. So 56 divided by 110, and I get 0.51. I'm going to multiply this by 100%, and I get 51%. Same thing with oxygen. I got 64 grams from the oxygen divided by 110 grams. 64 divided by 110 gives me 0.58. So 0.58 there, multiplied by 100%, and it gives me 58%. Now I'm glad this one came up. Told you to check yourself, you add it to get 100. Well, look at this one. You get 51 plus 58, and it gives you 99. Guess what? Since we are rounding here, all right, every once in a while, it might not give you exactly 100. It might give you something like this, 99, close enough, okay? So you got your 51% and your 58%. All right, one last problem to show. Right here, this one's even easier because look at this. What is percent composition of carbon and oxygen compound given 190.4 gram sample of a compound that contains 81.6 grams carbon and 180.8 grams oxygen? Well, look what they did here. They actually went ahead and gave you the total mass. You don't even have to add these